Okay, I'm recording this a day early so that you have more time to watch it. So first off, test one is this week. I don't remember when it closes. Wednesday. 5 problems you're going to have to show your work on. You may not use any outside resources on this test. Doing so is cheating and will result in an F in the course. These 5 questions, look, I don't care what order you do them in your scratch work, but please make it easy for me to grade. Write them up in order and upload it as a single document in the assignment called Test 1 Work. And you have to submit that before you submit the actual test. Okay, we've got this group assignment. This is the main reason I wanted to do this early. Coming up. Let me go to the calendar. There, here, go here. I've had a few people email me about this assignment saying that there weren't any examples similar to this. Like, this is always the struggle, right? How many examples do I need to force you to watch? How many should I make available? I thought the book had examples like this problem, but I couldn't find a single one in the book. So I posted an announcement that has a similar problem, and then I'm going to do one right now that's basically the same problem. And then, like, for fun, we'll find the equation of a tangent line too. Okay, so let's. All right, let's say we've got, I don't know, f of x equals 1 over x plus 5. Okay, so for part A, let's find the derivative at a single point at a number x equals 3. That will be, by definition, the limit as h approaches 0. Excuse me, f of 3 plus h minus f of 3 all over h. So this is exactly what you would be writing up. F of 3 plus h means instead of writing x, write 3 plus h. But rewrite everything else, including the plus 5. F of 3 means instead of writing x, just write 3. And notice we're all over h here. We'll be at every step. Okay, we could clean this up a little bit. Excuse me. When we do this in a minute with a function, we won't be able to do this step, but why not? In fact, you know what? I'm not even going to clean it up. Sure, I can make that 1/8 and I can make that an 8. I'm going to pretend I didn't even notice I can add those together. What I need to do now is get a common denominator. And we get that by multiplying these denominators together. So we're going to multiply top and bottom of this guy by 3 plus 5, which I know is just 8, but I'm doing this the long way because in the next part, we're going to have to. Oops, sorry, that's a minus. And then this guy, we're going to multiply top and bottom by that other denominator. In parentheses, you do need these parentheses here. And again, that's still all over h. And we're going to write limit as h goes to 0 all the way down. Okay, now I've got a common denominator. I can just add the tops. So I do that by, like, 1 times anything is just 1, and I'm going to distribute this minus. So I'm going to get 3 plus 5 minus 3 minus h minus 5, distributing that minus, over 3 plus h plus 5 times 3 plus 5, which I know is just 8, all over big fraction bar h. 3 is going to cancel. The 5 is going to cancel. I'm going to get limit as h goes to 0 of negative h over 3 plus h plus 5. times 3 plus 5 all over h. Now we're going to think, how do you divide fractions? Keep, change, flip. So that's limit as h goes to 0 of negative h over, like maybe I should have added the 3 and the 5 here, so I would have a little less writing. Dividing by h over 1 is the same as multiplying by 1 over h. This is my big fraction bar here. It's this fraction divided by this one. Hey, look, my h cancels. If an h doesn't cancel, you're taking a derivative wrong. So I get negative 1 over, and now, like, I'm tired of writing all that. I'm going to go ahead and add those together. What do we got there? 8 plus h times 8. Now that the h has canceled, I can actually take the limit by plugging in h equals 0. So I'm not going to write limit anymore because I'm actually doing the limit. Oops. Negative 1 over, and I'll write out the step, 8 plus 0 times 8, which is what, negative 1/64. Okay, so that's finding the derivative at a particular x value, at what, 3? Now let's do it in general. So f prime of x would be the limit as h approaches 0 of f of x plus h minus f of x all over h. By the way, like I looked through some of your drafts. You probably got this from the book. It is true that you can also find the derivative at, say, a by doing the limit as x approaches a of f of x minus f of a over x minus a. This is an alternate definition of the derivative. When I took this class, we had to learn both methods. I'm never going to ask you to use this version, even though it is nice because this looks more like change in y over change in x. This looks like a slope because that's all that is, change in y over change in x. I have just found that using this version, students struggle with a lot more. The algebra is easier in this version. So this is the one I'm going to always use. This is what I expect from you. Okay. So f of x plus h, remember f of x was way up here. So I'm going to replace x with x plus h. And I'm going to write limit at every step. Minus f of x, that's the original. That was x plus 1 over x plus 5 all over h. And then same idea, I'm going to get a common denominator just by multiplying these together. So this guy here, I'm going to have to multiply top and bottom by x plus 5. And I do need these parentheses here. And this guy, I'm going to multiply top and bottom by all of this. Now I've got a common denominator. And don't forget, all over h. Every step, we're going to have all over h until we actually cancel the h. Okay, now I'm going to distribute that minus. So what do we get? We get x plus 5 minus x minus h minus 5. That's all over this stuff. And don't forget oops. That's a 5 there. All over big fraction bar h. And look what happens, exact same stuff. That's a minus h though. So we get limit as h approaches 0 of negative h over, and we're going to do the exact same trick we did a minute ago. Think of this as h over 1. So a fraction divided by a fraction. Keep this one. Change divided to multiply and flip this over. And hey, look, the h is canceled. And now we get limit as h goes to 0 of negative 1 over x plus h plus 5 times x plus 5. I remember when I first learned this, it would be at this moment that I would get lost and be like, wait a minute, I don't remember what to do. Like way back in the day, this used to confuse me, this next step. Now we're actually taking the limit. Anytime somebody asks you to take a limit, first thing you always try is plugging it in. Like we could have way up here plugged in h equals 0, but you would get 0 over 0. Anytime you get 0 over 0, that means something's going to cancel. The thing that's giving you 0 is going to cancel. And that's exactly what happened right there. The h canceled. Now we try again. We plug in h equals 0. I don't write limit anymore because now I'm actually doing the limit. It's plus 0. I'm just writing that for your benefit, that 0 there. So I think we get -1 over x plus 5 squared. So that's the derivative. F prime as a function is -1 over x plus 5 squared. So now if I wanted to use that guy to calculate f prime of 3 plus 5 squared, I get -1 over 64, the same thing I got the other time. Okay, now let's use that. Let's, for fun, find the equation, that's shorthand for equation, of the tangent line. I'm going to upload this document so you'll be able to look through this at, let's say, 3/1/8, right? In the original, if I plug in 3, f of 3 is 1/8. Okay, so remember, anytime somebody asks you for equation of a tangent line, point slope form is acceptable if it's written. If it's a homework problem, they might want the answer in slope intercept form, but anything written, you can always use point slope form here. I know that. That's 3. That was given. That's the y value on the original. Right there. Like I plugged 3 into the original function to get 1/8. And slope is the derivative at 3, which we got was -1/64. So now we just fill everything in. Y minus 1/8 equals -1/64, x minus 3. And again, if you needed this in slope intercept form, you would have to distribute and then add over. Back in college algebra, we would care about that. Nowadays, like we've done all the hard work. I don't want to deal with the arithmetic of putting this in slope intercept form. So we're just like, whatever, that's good enough. We're done. Okay. And again, I'll upload that document. It will be in the announcement for this assignment. Where is, there we go. Okay. Stuff that's coming up this week. I'm going to do another meeting on Thursday and do some more examples for you if you need them. Your main thing is get the test done. This week, we're doing differentiation rules. Like you got to know all the rules. Product rule is going to confuse you. Once we get to chain rule was the hardest one. Like you really got to practice. I will post an announcement. I did like an extra hour-long video going through a whole bunch of derivative examples. I don't want to make that required, but I will post an announcement with that and with the document so you can try a whole bunch of extra derivatives on your own. Okay, we'll talk about some of this stuff on Thursday. I think that's good for now.